It's 3 minutes to go. Why is that? Yesterday also I had class and it was like half empty. Is it like people are slow to get going again, or they already?
I think they're like having trouble getting back from break because I know of at least 3 people in my other bunch that missed their flights like entirely.
Why?
I have no idea.
Bad planning, or there's no like snowstorm
Yeah,
to blame it on.
maybe they're lost in the airport.
Yeah.
Is it
It's
something like coaching?
yeah.
I asked I was talking to Ethan yesterday about it, and he was like, no, there's a lot of he's like, no, you have to define the decision.
Oh, so you're saying
So I'm going to talk about it as he did or Dude, I think for 9 hours probably previously with someone else. I wasn't done until 8 in the morning. Oh, I got it.
6 hours, I think, number one, or still number 11 hours. I don't know how to do it.
How's your break, Peter?
It changed. I like the old one better.
I'm working on it. Sorry? No, I'm a grad student.
you're out here
No, next year I'm 1 more year. If I have time. I'm taking 4 classes next year. You're teaching both of your software courses in the fall, right?
No. I'm teaching this.
You're showing a lot of
Just the same. Okay.
Which is more like a business oriented.
Oh, right. It's the course we taught last fall, right? Okay, Johnson. Yeah.
I tweaked the name to make it a little bit more Okay, everybody, while we wait for the tricklers to trickle in, if you wouldn't mind going to the course website and looking at what topics are slated to be coming up between now and the end, and think about what you would love to see us spend time on that's listed or that's not listed. And make mental note of them, because now we're in the on-demand TV version part of this course where I just teach what you guys want. So I want you to tell me. I mean, I have stuff that's worked in the past, but I'm definitely willing to bring in new material or whatever. So starting at April 14th to the end, which is like 4 or 5 more classes, think about what you would like to cover, and also cover again if that's what you want. And you can look at the course website. You'll see some stuff that I have slated just from the last one.
Oh, and Gio,
Yes, sir.
did you totally watch Halt and Catch Fire?
I did.
Did you like it?
I liked it because it had a lot of very accurate historical references. The sun is possible, but I liked it. It had so much stuff that you thought you knew that guy. I read that book. I read that book.
Wait, you went in Congress?
he still has a comment.
Yes.
For the Socrative thing,
Yes.
I don't know if mine's just broken, but when I click the logo on the upper left, it's not linking me back to the page. Like, and can I submit multiple answers?
Yes, you can.
Let's
Yeah.
just overwrite my old one?
No.
Okay.
And then I'll do a histogram.
Okay.
In fact, there's no reason why. Okay, so put some notes in there, guys.
Yeah.
Right now, we're very basic. One didn't work.
You can also put on there, don't bother covering X. If you see something that's X in there.
We prefer words on our.
Have you shrunk?
Okay, so you can put the last one there.
Oh.
Very surprised.
Oh, not sure.
Oh, no.
Last time I put it generates that one.
Say vote, bro.
Okay, everybody put something up there. Okay, I'm going to hide this again because now you guys are copying each other.
Yeah.
Also, something you say, don't bother, like, I don't need to cover regular expressions. That's one that's in there. Huh? Curacao. The little island in the Caribbean next to the Cuba.
Oh, that is the reading right now.
Yeah, that's
Is that your first language?
Continental is my first language. Dutch is my second language. English is my third language.
Really?
Spanish is my fourth language.
Wait, is that a Native American language? Indigenous American?
It's a language that was developed through the interaction of slaves with their owners. And so it's got a combination of many languages. Okay, if you're done putting in your remember you can say don't cover this also. I don't care about regular expressions. I don't care about Scrum. Or you can say what you want to cover.
Just put on this one.
Great. Okay, I see a pattern here. Can I have a job? Depends. So with these things, it's only a matter of time before you start seeing wise-ass answers. Okay, a couple more, and then I'm going to hit this button, which I don't really know what it does. Start vote, so we'll find out. But this is perfect. This is exactly what I wanted. So this is very good. Oh, great. Don't bother with security. Well, you lose because 3 people want it.
You gotta reset your migrations.
Okay. All right. Okay. All right. So yeah, there's a lecture already scheduled called Real World Survival Kit. Sounds like we want that. I got some really good scaling material from another class, which I'll throw in. Okay. I think we're good. I'm going to hit this button just to see what happens. Start a vote. Did anything happen on your screens? Okay, start voting. Whatever that means. Zero. Oh, here we go. Ah. That's cool. All right. Keep voting. Boom. Boom. Hey, this is actually kind of cool.
They should have like, so like if you put the same word in, it should count as one.
You should write one. Make this happen. Be a good Rails app. Yeah.
Saying it could scale with it.
Yeah, I agree. Same word root, scale, scaling, scale, scalability, all be the same thing. That would be good. All right. I think we're pretty clear here what's going on here. Bootstrap only got 1. Okay. Job's got a lot. Scaling's going up. Good. All right. All right. Everybody done? Okay. Good. Excellent. Thank you. I like this app, especially because it's free. Woo!
For now.
For now, exactly. Yep. All right. Thank you very much. All right. Where are we? This is it. Okay. So, how did it go with the homework? Particularly, did everybody get stuff up on CodeShip?
No.
Yeah. Was it pretty easy? Did you try?
Yeah, we having trouble getting.
What kind? Any just stupid stuff or something worth discussing?
I don't know. It says like to push, and then it'll trigger a bill.
Yeah.
So we push, but it doesn't trigger a bill.
Interesting. Okay. I'm sure you can sort it out.
Yeah.
Anybody else sort of stumped on CodeShip? Everybody else good? Okay, good, excellent. And I'm sure everybody's good with getting their code climate badge with the trivial, right? Anybody have trouble with that? Nope. What grade did you get? A's? From CodeShip. I mean, from code climate. What grade did you guys get?
2.7.
What letter?
C plus.
Anybody do better than a C plus?
2.9.
Okay, a little better. Anybody better than 2.9?
Well, it's green.
I'm colorblind. I'm colorblind. I just see letters. Did you guys get it on code climate back there? You're very quiet. You guys get it on code climate?
Not yet, I'm still working on
So only 2 people succeeded. Trouble. I'm a little punchy.
Oh, I see.
Okay, good. So tomorrow, I want to point out this to you in case you didn't notice. We're going to have little presentations on your products. They're going to be very brief. They're going to have 2 things. One of them is you're going to show the class your list of loose ends. Why is that there? Because I heard from several of the product reviewers that you guys didn't have good lists of loose ends. What is a list of loose ends? Anybody still confused about that? Yeah? You know what we're talking about? Yeah. Anybody confused about what the idea of a loose ends list or a punch list, whatever you want to call it? It's not build the product or create the UI. It is much more granular. It's something that you could literally say, I'll work for an hour and do that. And it's important because, and by the way, you make it in the context of your planned demonstration. If your planned demonstration hits a point and, whoa, we said there's a graph here, but there's no graph here. Somebody got to put the graph in. That's what you put on your loose ends list. If your loose ends list does not have at least 10 legitimate entries, I'm going to call, what would I call? I'm going to call penalty on you. Because I know you all have at least 10 real entries. And obviously I don't care as much about the list, but that you guys go through as a team to look at that list and create it, okay? That's one thing, and the second thing is to do the showcase day demo, to the extent you can and as realistically as you can. I'm allotting only 5 to 10 minutes apiece, so we'll go through it really quick. And the remaining time will be spent just working with your teams and working with us on your products. Sound good? Good. Hey. Okay, so the last lecture, I think I want to just pick up some stuff that we did not get to. So basically, we got up to techniques of asynchronous processing. So the topic was basically what does scaling mean, if you remember. And given that there was so much interest, I'm going to create a lecture. For those of you who are also taking 105, which is only 1 or 2 of you, will see a repeat. But I've got a lot of really interesting, in my opinion, scaling-related material. And actually in 105, it's kind of cool. We are having all the projects get free accounts on a site called loader.io. And you can all do this as well. And that generates what they call a synthetic load. So you can say, what will my site do if it has 300 users hitting on it? And then you will see horrible looking graphs that look like this. Response time as the thing falls over. And the question is, does it fall over with 10 users or does it last until it has 200 users? Or better still, 2,000. You don't have to do this. I'm just giving you this as a kind of an entertaining thing to do to see really what you got. Because we really haven't talked about scaling too much in this class. But basically, all scaling is all about getting your resources to do to be exploited efficiently and maximally. That is to say, your CPU should not be idle. Your network should not be being wasted. Things should not be waiting for the network. So in general, it's all about employing your resources as well as possible, and then in greater, if that doesn't give you enough scale, then it is, okay, if I add resources, like add another computer, how do I deploy that to the max? If I add another computer to contain my images, and that computer, which costs me $1,000 a month, is sitting there not doing anything, then I've not done a good job in my architecture. But that's really what scaling is all about. And and there's a load of techniques. All these techniques are built upon computer science research that has been happening for the last 25 years. So you, as a modern developer, have the advantage of sitting on top of this unbelievable stack of technology, but that doesn't mean it's easy. So there's things like, very sophisticated ways of managing concurrency and parallelism. There's very sophisticated ways of handling inter-process communication. Very sophisticated ways of handling queuing. If you have two servers sharing the load, ways of making one server request service from the other. There's very sophisticated ways of dealing with databases to get to scale. So each of these things is a topic that I can give you, an hour interesting discussion about. But the point is that to achieve scale, you have to first understand what the load is you're trying to support. And then once you understand that, you have to test that load, and you have to find out what happens to be slow. A little anecdote out of 105, which we haven't solved yet, but there we're building Nano Twitter, which is every team of 3 or 4 students is implementing a Twitter service. And we put it under loader.io and start hitting it and see what happens. And people often, because I talk about these sophisticated techniques, start going like, oh, we should put in some queuing. Turns out that you got to first go for the low-hanging fruit, the easy stuff. And so they're having, because there's commands you can give Heroku, they're having like one SQL query that's killing the whole server. It has nothing to do with anything fancy. It's probably a missing index or a join that's wrong. So the low-hanging fruit often is enough to get you to a pretty high plateau. But once you sort of reach that, if you're like working at, at Periscope or working at, Instagram or working wherever, and they say you're going to work on the scalability team, they've got the easy stuff out of the way, and then you get into much more sophisticated stuff like scaling out by building additional queuing coordination, by dealing with multi-core processors, deciding whether you want to add a ton of memory or whether you're better off adding on the CPU, things like that that come into play. So one of the difficult things which I haven't mastered myself is to understand what kind of load to put on a service, like something like loader.io, that helps me learn anything useful. In other words, if my service runs with 1 second response time up to 100 simultaneous users, is that good enough? Or should I have it run well with 1,000 users? And secondly, what does running well mean? When the response time goes south, what is actually going wrong? So one way to think about scalability is see how I wrote this up here. Right. So there's two scenarios. If you think about the scenario of I have 1,000 users refreshing my home page, that's one scenario. It's going too slow. But the other scenario is I'm having, and that's just a refresh, and I just have load bringing over data. But it could be an operation. Like I need to be able to have, 100 emails sent out per hour, where nobody's waiting for it. But it's more of it's not a response time. How quickly does it come back to me? But it's what's the word? A throughput issue. How many of these can I do? It doesn't matter to me too much how long it takes for my system to send an email because nobody's sitting there waiting for it. What matters to me is, every time somebody creates a new account, I have to send them an email, and I want to be able to handle 1,000 new account creations per minute. And can my infrastructure do that? So there's two different ways of handling it. And basically, if you look at the scenarios under which that fails, okay, the possibilities are this. If you think about, let me just put the board up. Maybe if I mute this, will that do it? I think so. No, it doesn't. Okay. Ha! There's a little error here. This up-down says screen controls. No. Oh, it is also screen. Actually, I think about it. It's an old-fashioned screen. Okay, I was thinking it was computer screen. Okay, so basically, if you look at the infrastructure, I want black. If you look at the infrastructure of the darkest color of any one of these services I mentioned, basically they always have a ton of servers, and they do different jobs. Okay, classically, of course, you have a web server, and they're all collections of them, which handles the returning HTML. But you almost always have a database server, which handles the database. And you might have another server, let's say an authentication server, which is handling the logins. And you might have another one, which is an image server, which handles all the images. The point is that when people design a system and they want it to scale, the ideal architecture, which is very difficult to achieve, by the way, is to have code that runs on a server that does one job and architect it so that if you need to add another server doing that same job, it works. And that's very tricky. Without going into the gnarly details, it's very tricky. But that's the ideal. Because now the question you have is, if this thing is running slowly, is it that there's too many requests of type X, like too many requests for resizing an image? Oops. In which case, can I add another one? Or is it any individual request? There's not so many of them, but they have to be fast. If one person going to a web page refreshing takes over, 300 milliseconds, I don't really care about the same person being able to refresh a million times. That 300 milliseconds has to be reduced. That may not be possible by adding another server, because it's one person, and in the end, one person's work is going to be handled. Well, that's kind of a hand wave by a server. So you have to. So the possibilities are either you have to add additional servers of a certain type, or you have to find a way to have the users request that less often. Now you might say, how do you do that? Well, caching is one way you do that, right? If a very important part of scalability is caching services, like things like Redis, I'm sure you've heard that word. And a caching service says, and we've talked about caching before many times, if a request like for the profile picture comes up a lot and my image server is not able to handle that any quicker than 300 milliseconds, maybe we can put in a caching server to avoid asking for the image altogether, because we have a subset of the images, maybe the currently logged in people, maybe the currently even active people, and we can use a caching service. So scaling solutions have to do with these kinds of considerations. So what I'll do, I'm going to find another day to go into this in more detail. I'm going to pick a couple of these. In fact, let me just do a quick vote, because I can't do them all. Who wants to learn more about database partitioning, which is how you break up a data model into many databases? Who wants to learn more about Redis, caching? Okay. Who wants to learn more about concurrency, threading, and parallelism, and so on? Everybody, okay, none of them is a big hit. Okay, these guys are small. Who wants to learn more about queuing systems like you might have heard of Rabbit and Qubit, and any of them. But basically queuing systems. I don't see any hands. Oh, I do see some hands. Okay. So, okay, I'll see how I work with that. There was none. They were all sort of like, none of them got a big, exciting one. So I could also squeeze them all into one lecture. Okay. So, here's, oops, I put this thing back on. Here's another point. If you think about the actions you can take when, if you think about the actions you can take, another action is, what is the reason why a client would ask for Operation P so often? I mean, Operation P is slow. I could try to speed up Operation P, or I can examine why is Operation P getting asked for so often. I'll give you an example. How many tweets are shown on the home page on a user's page in Twitter or in Nano Twitter? Let's say the number was 50. That means 50 times I have to look for the tweet in the database, or 50 times I have to find the profile image. Well, if I change the default to 40, something as simple as that, I've just reduced the number of times that request is made, and I've achieved greater scale. I can support more users. It could be that I decide that I won't display the user's profile picture on every tweet. Suddenly I've removed a ton of requests for images. So there are approaches to improving scalability which have to do with not so much speeding things up, but by changing the user experience into a way that will end up hitting the server less often. Okay. Okay. So that's basically some of the strategies you can use when you find a scalability problem. But the very important point here that I'll re-emphasize, that's true for scalability, it's true for performance. Whatever you believe in your intuition is the reason why your product is slow is probably wrong. Worse, whatever you believe before you write the code that will be the part of your product that is slow is probably wrong. So here the scientific method really comes into play. If you care about performance, measure carefully and determine either by observation or by experimentation where the slow parts are, and then go work on them. Also, build something simple, get it to work, instead of build something anticipating performance problems and making it much more complex to address those possible performance problems. Better to get it to work slow and then speed it up in the right places than think you know ahead of time what's going to make it fast. And that's true for scale, and it's true for straight out performance, slowness. And it's part of the general keep it simple, stupid philosophy, or you're not going to need it philosophy. These are all traps that you fall into, not just with software engineering, but with projects in general. But it applies especially here because one of the real pitfalls when you try to create an architecture which performs better is that you're creating complexity, which means you're creating bugs, which means you're going to create reliability problems. So get it to work, then worry about making it fast. I thought I saw a hand, but it seems to be gone. Okay. Now, let's go to today's. So today I want to cover, so that was just left over from before. Today I want to cover some of the aspects of not so much programming or architecture, but software engineering from the perspective, or that come into play when you're building bigger products. And one of the things that happens when you're building bigger products is you're working on teams, right? And so there's a number, and I won't follow this exactly. We'll just free associate a little bit because there's too much here to cover. Who has any of you? I mean, I think these projects are not quite big enough for the issues to come into play. But I mean, there's certain elementary things that have been well established to work, and I think those you're practicing, like using source code management. Like any job you take in academia or in business, if it involves software, you're going to be using source code management. And you guys are using Git. You might encounter other products, but the principles are roughly the same, and the same enough that you're prepared there. Okay, so but that's one that comes in not so much for a sole programmer's benefit, although I use it by myself. It comes in from into the picture when you're building big software products. So that's one fundamental and essential and good hygiene. But the second thing is, how do you manage a project? And what are some of the, imagine you guys all were working on one product. I want to get you to talk a little bit here. You're all working, you're developing software together, you're all working on the next big video application to record, interactions with friends. You're all programmers or all technical people. What are some of the challenges you might encounter in doing that? Use your imagination, use your own experience. I mean, there's some obvious ones and some less obvious ones. Yeah.
This one is waiting for someone else's part to finish before you can start.
Absolutely, yeah, okay.
Merge conflicts.
Pardon me?
Merge conflicts.
Merge conflicts, what are those? Yeah, we know them, yeah. Oh, excuse me. Okay, merge conflicts. What other, how about interpersonal problems that you might get? Organizational problems.
Working with like multiple teams at once.
Yeah. Why is that a problem?
I mean, I don't know. Considering here there's like 30 people,
Yeah.
bringing it out into like 6 teams,
Uh-huh.
all working on one.
So your underlying belief there is smaller teams are better. Why?
Oh no, it's more just like the amount of teams on one product, or one aspect of the product.
Not the amount of people or amount of teams.
Teams.
Okay. Anybody else want to talk about that? Yo, Saul. Any thoughts about this? Okay.
I was fixing the bugs.
Okay. We're in class now. We're not fixing bugs. Just FYI. Anybody else from this side? What are some of the problems? And we got all working. Okay, tomorrow we start over. It's a big project. We have 3 months. We're going to build this product. What's the first thing we do to be effective as a team? Yes.
So you have to write out everything in paper, like all the documentation of the what the project is going to be like, what the functionality is.
No, that's terrible. Okay, that's an interesting point though, because he says, you know, I mean, there's a grain of truth in that. But that's in the bad old days, we used to say, okay, let's ask the business people what this product has to do, write it all down in gory detail, and then we'll just give it to the programmers and they're built it, and 3 months later or 12 months later, it'll be done. What are the major pitfalls with doing that? Yes.
You need to find a customer for that afterwards.
That's very true. You could have been wrong, but let's say you had a customer. I agree, but even if you have a customer, what are some of the big problems that can occur if you do that?
Like if you want to make a change on the fly that doesn't like fit into the big picture, it could mess everything up.
Okay, anybody else? Yes?
I feel like there's always going to be a mismatch between what the programmer envisions in his head
Yeah.
and what the business person envisions in his head.
Absolutely true.
So
Yeah.
I think your first step should be to have like a workable prototype.
Yeah, absolutely. Yes, go ahead.
I think there's a similarity between what the pitfall of TDD is,
Yeah.
and that is as you're going, if you wanted to be creative or you wanted to add some very good things or things that are going to make it much better
Yeah.
in performance,
Yeah.
you can't do that because you're prescribed by the business people
Right.
what to do.
Yeah, that's true, but yes,
The customer might not
you're right,
know what they
extremely small.
do.
But still a lot of white space. Yeah. Sorry, go ahead.
White space is over there.
Yeah.
The customer may not know what they need.
Absolutely true. Well, how could that happen? How could that happen? I'm going to go to you guys. You're this new web company, and I am a music venue, and I have artists that come in all the time, and I've been doing this on 305 cards. But I want a website to run my music venue. How can I not explain to me why I could possibly not know what I want? I've been running this by hand for years. Go ahead.
You might not even need a website and source that immediately.
Okay, so you may not be aware of options you have out there. Yeah, anybody else?
You don't really know how the website even works if you're not educated, so you don't really know what can be done, can't be done.
Absolutely right. You don't know what can be done and what cannot be done. Very true, yes.
There might be technical components that a non-technical person doesn't even understand that might lead to really significant problems.
Absolutely true. Anybody else? I mean, a big one that happens all the time is it's true, the customer does not know what they want. They've seen websites, they've used Amazon and Facebook, but when it comes to their website, do you want to organize the shows on a calendar or on a list? Do you think you need to have an image attached with every show? Just one image? Do you think you have multiple images?
So instead of a streaming version,
Yeah, do you want to have video streaming? By the way, do you want to divide it up by music style, genre, or do you want to put them all together? Oh, what do you want to put on the homepage exactly? What do you call the type of music that you could show? That's the kind of questions you need, and 100,000 more that they may never have thought about.
well, it's like designing a like website for cosplays, which is like I don't know. I mean, in terms of like using a specific example.
Yeah, absolutely. Absolutely, yes, go ahead.
I think in general, people like tend to think of things very generally.
Yeah.
So they don't think of edge cases or whatever.
Absolutely,
So,
yeah.
I think as a programmer who's used to thinking in edge cases, used to like fleshing something out to its fullest, it's your responsibility to explain that to the person.
Yeah, absolutely, and it's edge cases, but it's simply, I mean, everybody's touched on it a little bit. It's also simply knowing, first of all, as a developer, not even as a programmer, but just as the designer that's trying to assemble the structure, there's a million questions that will come up that the client never even thought of. They never even thought of. Now, the big problem and the big reason why is, in many contexts, a really bad idea to say, hey, client, give me what you need, write me all the details, and I'll go implement it, is that the client always changes their mind. Or the world changes its mind on the client. In the 3 months that go by, suddenly they decide that they're going to open a restaurant as well on the venue, and suddenly a lot of the details that they had are wrong. Or suddenly they decide that they want to sell tickets as well. If you said, oh, the spec you gave me on day one is locked in until 4 months from now, until you ship it, until it's done, you're going to have a very, very unhappy customer. It's not like building a skyscraper. Although I hear it say that nowadays, not even nowadays, for years now, they will begin building the lower floors of the skyscraper before they've designed the top. Okay? So there's a little bit of that too, but it's a different world because you're working with solid materials, so once you pour the concrete, it's kind of hard to change. So the notion that I'm sort of working my way up to is why is it that we talk about things like agile methodology and extreme programming and so on? Yes?
Since you want to be able to change on the fly because customers will change their mind.
Exactly. So these methodologies, they're all similar but different. They all, are basically the collective wisdom of software workers over the years. They're not uncontroversial. I mean, they're a fad now, but you'll find people that don't like them. I happen to believe in them in a general sense. And having worked in this context myself, through both spans, before and after these things were popular, I've experienced that idea of write down the detailed requirements and then go build it. And I've experienced the incredible organizational crisis you get into when the development team is working around the clock to finish the spec by a certain date. Why is the date so important? Oh, because the marketing people have spent $1 million on advertising, and they've printed brochures, and they've reserved time, on CNBC for August 14 launch. And if it's not ready by August 14th, we're going to look terrible. Okay, there's got to be shipped on August 14th, and we're building the spec. And then on April 15th, the CEO comes in and says, you know what? We've just found out that the only way this product is going to be successful is if in addition to audio, we also have video. Can you guys add it? You know what happens? War. People get very, very upset because they've been taught that if they work hard and hit the date, then they're successful. And the contract is, you tell me what to do and I'll do it. Well, that's a long time ago. We don't do that anymore. What we do now is we say, the general characteristic that all these different Scrum dialects, or rather Agile dialects have in common is we work on short iterations. The iterations can be 2 weeks, 1 week, 2 weeks, 4 weeks. And the basic principle is, and we've sort of talked about these terms vaguely in class, is that the stakeholders, they call them, the people that care about what's in the product, agree to a list of features or stories that will be implemented in the next sprint or iteration of 2 weeks. And that during those 2 weeks, the contract is the developers will work their asses off to build those features by the end. And at the end of those 2 weeks, I'm using 2 as examples, there's an evaluation that says, okay, we said we were going to build features A, B, C, D. We've only built features A, B, and C. Oops. Okay, set that aside for a moment. Now let's look at the list of features that have to be built. Let's prioritize them again, given what we know today. And what was top last 2 weeks ago may not be top anymore, but we'll take the top N of those and we'll build them in the next iteration. So instead of change being an exception that causes angst and upset and battles, change becomes expected. It becomes part of the process, and nobody really blinks. Now, there's various challenges that working this way introduces. Okay? Anybody can think of right off the bat some challenges that working this way would introduce? What kind of thing might be difficult to do in this scenario? It's one that always comes up. Yes?
Unexpected problems during disaster recovery.
In other words, we said you were going to do these 5, but you only did 1.
Yeah.
Right, absolutely. That's a feeling, well, I agree, I'll get to that. But what is sort of inherent that is immediately like, wait a minute, put yourself in the shoes. In the shoes of the developer who's negotiating these features to be done in the next 2 weeks, and you have to commit to doing them. Which ones do you do? What are some of the challenges? Well, one that always jumps out is, what if the task will take more than 2 weeks? What about a task that's longer than 1 sprint? How do we handle that? And the answer is, you divide it up. The forcing factor is not so much that, add Excel import and export to the product is a feature and it has to fit within the 2-week sprint. No. The forcing factor is no task, no story should take more than 2 weeks to implement. If it seems to, it's too big. We talk about epics. An epic, this is not a totally universal term, but you will hear it. An epic is a story that's actually a collection of stories. And before it gets to the front of the queue, it will have been divided up into stories that are 2 weeks or less. So that's one issue that comes up. Now, nobody asked me, how does the development team know if, by the way, is this interesting? Because I'm going on much longer on it than I expected. Do this if you think it's interesting, or not if you don't think it's interesting. I can tell from your eyes that you think it's interesting. I get a pretty good idea. Because I wasn't planning to spend too much time on it, but I seem to have your attention. So how does the development team know? Because they have a meeting at the beginning of the sprint, and there's this long list which we call the backlog, and I generally draw it like this, and it's got stories on it, and this is the most important. And the meeting at the beginning of the sprint is between the stakeholders and the development team, and they say, starting at the top, working down, how many do you want to do? I'll do this, I'll do this, I'll do this, and that's what it's all about. Now, how is that done? In the old way of thinking about things, there was a lot of pressure on the developer to do an accurate estimate that said, I can do Excel import and export in a day and a half. And the other developer would say, and I can add a new alerting mechanism in 6 days. And they would go through and make an estimate. And you know what? Then there'd be a gun to their head, metaphor. And they would feel an obligation to do that in that amount of time. And if they were failed, they would work around the clock. They would burn themselves out. There would be what they call a forced march. And if they failed often enough, they would get fired. Now, this is very unfortunate, because the truth is you can't estimate with that much accuracy over and over again. The truth is you get better, much better at it as you get more experience. You get an intuition about it, but it's very, very difficult. Not only that, but people have different reasons to not be able to do the full. This is also an argument you get into. Well, I have a lot of meetings. Oh, well, you guys are always making us do these reports. Oh, well, I have to take these customer calls. All these reasons why I can't do the thing in the time I said I was going to do it. So the new way of thinking is we don't decide top down how many hours of productivity every developer has. We don't take the estimate in hours for this story and this story and this story and this story, add them up, divide by the number of workers we have, boom, we go down until we have 2 weeks worth. We don't do that. Because that sort of leads to the problem I was talking about. So what we do instead is we assign each story a value, which is definitely not a value in terms of hours or days. People talk about things like story points, or let's just call them story points. You basically, you could just call it like easy, medium, or hard. Very, very rough. But let's call this, and so this could be one story point, this could be 2 story points, this could be 3 story points. Okay? And I'll get to how these numbers are summed, but they're emphatically not meant to correspond to time, because nobody knows. You also notice that the resolution is much less granular. We don't have between 1 and 100. We have between 1 and 3, between 1 and 5. Then each story gets assigned a number, and I'm going to get back to very quickly how the number gets assigned. Let's say this is a 3, this is a 1, this is a 0, this is a 2, this is a 2, this is 3. So up to here we have 3, 4, 6, 8, 11. We've also determined, and I will explain in a second how, that this particular team, with these particular people, at this particular time, has a velocity, another term, velocity, of 11 points per sprint. 11 points per sprint. We know that. I'm going to tell you how we know that. I don't want to throw something at it. It has a velocity of 11. Okay? How do we know that? Well, because last sprint, even though they committed to 15 points worth of work, they only finished 11. Or maybe you say, the last 3 sprints, on average, this team right now, with these people in this state of health, on average over the last 3 sprints, they finished 11 points. And so we just, instead of forecasting it, we measure it. Instead of forecasting the productivity or how many, this guy's really fast, this guy's slow, we measure it. Yes?
I'm sorry, how do you assign the points?
Yes. Okay. Exactly. It's an iterative process. Many different ways, okay? One common way is simply that. Use your own experience. Is this small, medium, or hard? Is it easy or not, or in the middle? Furthermore, sorry, I get to you in a second. Furthermore, compare it with a task or a story you did in the recent past. It is kind of like, I'm being asked to put the story points on import, export, Excel. Actually, 2 weeks ago, I did import, export CSV. That was easy. I think it's going to be a little harder, so I'm going to put this as a weekend. So you basically use that. Another way that's, I'm sorry, go ahead.
So how would Kanban be different from
Okay.
Scrum?
Okay. I'll come to Kanban in a second. I think Kanban is not quite as precisely defined, but it doesn't have any of these point systems. Kanban is I'll explain it in a second. Let me just finish this thread. So it's kind of a circular reference, right? The numbers are assigned more or less intuitively. The velocity is determined by measuring, and either you just take the sprint just before or the last 3 sprints, there are any number of ways of doing it, that'll forecast to you the next available velocity. And the beauty of this is A, it works, okay, and B, it's realistic. It does not reflect some arbitrary management belief that doing import-export of Excel should take 3.5 hours. It's measured empirically. Now you might say, seems like there's a lot of opportunity for gaming the system, right? Why don't these guys all just go slow, and the velocity will reflect that, and nobody can complain because we're just following the process? Well, real-world practice has revealed that if the team is bought off on this methodology, if they believe it works, if they want, if there's basically goodwill, that natural human competitiveness and natural human pride, craftsman's pride, and natural human desire to do a good job corrects for that. Now, it's true that if you have a big company and there's 10, and I believe like companies like something Hub. HubSpot does this. They do some very interesting things there. That if they have 10 teams, each of them have 5 people on them, and 9 of them are working at a velocity of 29, and 1 of them is working at a velocity of 3, you probably as a manager want to go check into that, see what's going on. Okay? So the features I've described so far are the iteration, or also called the Scrum, also has other names, which is the cyclical nature of this. I've described the idea of a story, which is a chunk of work that can be done during the duration of one sprint. I've described velocity, which is measured, not pre-computed. I've described story points, which is a way to estimate the complexity of a, or the degree of difficulty of a certain task. There's a few other ways of setting this. One of them is collaboratively. The developers, without marketing or management in the room, look at task 3, which is to add video, and they discuss it, and they debate it, and they say, well, I think it should be 3. Somebody says, oh, I think it should be 1. They argue, they come up with it. It becomes a collective observation. Another thing that's done sometimes is called story point poker, where everybody decides individually what they think it is, and they open their fingers and show 3, 2, 1, and everybody can see what everybody came up with without influencing each other, and they take the average or the median. So there's any number of things, and what you want to really do is tap into the collective wisdom to get a reasonably believable number of story points. The scale could be 0 to 3, it could be 0 to 10, but it's strongly not time. Okay, so that's story points. So anyway, that's the essence of Agile software development. Now let's see what I actually said here. Scrum, concepts, blah, 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 blah. Okay, very good. Now, if you look up extreme programming, there's a number of practices that go beyond this. This is the kind of the project management part of Agile, but there's also software engineering parts of Agile. Pair programming. Have any of you guys done pair programming on this project, or ever done it at all? No? Yes, you've done it? You've done it together?
I've been with Josh.
Okay. So what was it like, and what do you think of it as a practice? What is it, first of all, and what do you think of it as a practice?
Well, pair programming is like when two people are working on one computer and one person has like sometimes it's like one person has control of the keyboard and the other person has to control the mouse. But
Yeah. Where did you do this? At Brandeis or at a?
Just at Brandeis.
Yeah.
But like in undergrad, like there was this concept, but I never actually got to do it. But,
Gotcha.
But yeah, so it's like that idea, and then so basically it's just to you have two sets of eyes sort of working on the same problem, and then people can sort of like fill in the gaps of knowledge, if any, and sort of like double check like any possible like foolish errors that you.
Okay, so what do you guys think of pair programming intuitively? You think it's a good idea, bad idea, or you don't know yet? Yes.
I've done it, we've done it sometimes in our project here, and I think it might take a little bit more time because you're constantly discussing stuff. But
Yeah.
It definitely reduces time debugging and stuff because so you have less the code with less errors.
Yeah.
Yeah, I think we have done it also. I think it's more that it definitely takes longer, but there's definitely less errors because we're like reading over each other's shoulders and saying, oh, I think this is you missed something.
Yeah. So some other hands flying around. Oh yeah.
For the ACM programming competitions, there's always only one computer, so
Right.
generally it's useful to have like multiple people working on the same file. Though, like one person will have it in their head, and the other person will be just typing it out.
Yeah.
Just so they can catch the errors before the compile.
Yeah. Now let's say you're the manager, you're the CEO of this company. Do you make it mandatory that every programmer work with a pair always? Yeah. Okay. You want to say more than it depends? That's always a safe answer.
Well, if you're expecting a big project,
Yeah.
where there's going to be a lot of bugs,
Yeah.
programming, I guess, would solve your
Mandatory? Because there are companies that make it mandatory. You might go to an interview and they'll say, we just do pair programming. Yeah.
Almost any time
Uh-huh.
you have to be a little flexible.
Uh-huh.
It's obvious, like, sometimes that's not going to be
You have a cold or you're just very quiet today?
very allergic.
Okay, gotcha. I can hardly hear you.
Yeah, sorry.
That's okay.
Yeah.
Okay, yeah, you're right. No, I think that's a fair point. Yes. Did you
Honestly, pair programming sounds kind of unusual to me.
Yeah.
Just because traditionally, and obviously there are exceptions, but computer programming is an activity that's usually very like lonely, requires solitude,
Dark room, fresh room.
basement.
Okay.
Isn't that the image of a person doing that, in middle school, high school, whatever, but not in the real world. In the real world, you're working with other people, which is obviously what happens because they don't know how to work with other people.
Yeah, I I mean, it's interesting. That's an interesting point. I mean, it's true that programming is definitely not generally a solitary.
That's why we have GitHub, you know, so people do stuff that.
Don't have to talk to each other. Yeah, I agree. No, but I mean, but even to this day, there you will find, and maybe some of you are, some kind of like I don't know, weird people that are the most productive programmers you've ever found, but they cannot communicate with anybody. And as a manager, you want to create an environment where somebody like that, like throw them in a corner, lock the door, slip fresh meat under the bin, and trust them. And 3 months later, or not 3 months, but 3 weeks later, you get the most amazing amount of productivity. So that does happen, but by and large, you're very right. Programming is not a solitary activity, although all of us, I'm sure, I mean, I know, sometimes I have to, you know, when I'm doing something difficult, I'll turn off the music and I'll just have to focus just to get the, because it's a very, very intensely concentrating kind of activity. Yeah.
But in my intuition, I guess, it's just the opposite for me. If I'm working on a part of a project where it's a complicated, like a complicated algorithm that's implemented, or something really long that's going to be written down, then I would definitely use an extra set of eyes.
Yeah. I mean, there's a lot of debate about pair programming, to be honest. Some people say that it's a really great way to bring new people up to speed within a company, because you know they can have somebody who's more experienced or maybe far more experienced working with somebody new, and it's the most effective way to transfer the knowledge. Some people say that they consider it so effective at reducing bugs and increasing quality that they make it mandatory for everybody in their company. Some people say that they don't believe in it at all. Any of you that are thinking about going for a PhD and doing research, there are a lot of things in software engineering which are matters of opinion and anecdote and beliefs, which really could stand some serious research, some really good experimental research. This would be one of them. Like, under what circumstances is pair programming effective? I mean, that's a PhD thesis right there. If nobody's done it. You know? Yeah.
You know who obviously Dijkstra is, right?
Dr. is a
For years.
Obviously, the guy's been, sorry, dead for years.
Yeah, when he was a university professor and he was teaching doing research, he apparently didn't write a single line of code for years, and he had his grad students do like all the coding.
Hey, listen, that may be happening in our own farm.
Work hard, not work smart.
Yeah. No, I mean, you can be a very excellent and important computer scientist and not know how to program. No, I'm not kidding.
Algorithm is a mathematical.
Mathematics, yeah, there's a lot of stuff that's quite important that you can research without writing code or maybe having your grad student do it. But that doesn't go into your paper. That doesn't go into your research. No. But anyway, I've been interested in this of late. I've been reading a lot of papers about what I call experimental computer science, and realizing there's so many things that I say as a truism in this class or when I teach, which really is more a belief than a scientifically established fact. And there's a lot of, like, are dynamically typed languages more productive or less productive? You know, are object-oriented versus functional? Scrum. You know, there's all these things that we act on as if we know, but we really haven't been studying in detail scientifically. So anyway, that's a little advertisement for scientific research on software engineering. Okay, Kanban, really quick. So Kanban, as I understand it, you asked about Kanban. Do you know Kanban?
Very vague.
Okay, the way I understand it is that, and if you look at Trello, those of you who use Trello, it's very good for Kanban. Basically, they have something like stories, and they have stages a story goes into. So the stages might be proposed, coding, integration, deployment, or final test, deployment, and deployment. Okay, and you know the physical rendition of this is it's on a corkboard somewhere, and you put cards reflecting all the projects you have to do. Does anybody here speak whatever language the word Kanban comes from? Anybody speak Japanese? No? Because I know what it, well, you guys have Google. Let me know what it means. Little cards? No. Okay, but anyway, but the thing with Kanban is that the way you manage your
Billboard.
resources, pardon?
Billboard or signboard.
Okay, gotcha. The way, so that's kind of matches. The way you manage, and a card, of course, will move from one stage to the other. So at any point in time, if I now want to zoom up my diagram, I could have these here, and I could have these at this stage, only one in this stage, and like that, right? And the Kanban methodology says that none of these hues can exceed n in length, let's say 3 or 4. And if it threatens to exceed n in length, then everybody working on one of the other columns has to go help the people working on the column that's too long to shorten it again. And the idea is to force the flow through the process so nothing gets left behind and so no bottlenecks appear to prevent progress. And so Kanban, I believe, does not talk in terms of story points or sprints. You may integrate the two, but inherently it doesn't. It just says make our current state of work totally visible to everybody in the project and have a mentality or a culture in the project that says we will never put something, add something to, let's do it like this. This thing is finished. We're not allowed to add it to this because it would go to 4. So instead, everybody working on this has to go work on this to move at least one of them over here. And then we can actually move it over here. And that's basically Canada. That match sort of what you understood? Yeah. Okay. It's considered one of the Agile flavors. There's reference often to the Agile Manifesto, even though the people who wrote the Agile Manifesto now kind of like are annoyed about it. But they came up with 5 or 6 principles that they consider to be the fundamental tenets. And like anything, it was an inspiration. If they didn't write it down, somebody else would have written it down. It was sort of a point in time when there was a backlash against the way software engineering was managed previously, which was, you know, they talk about, okay, this is a test. It's a geekiness test. Do not go to Google. Who knows what this stands for? Beat off. Okay, go to Google. I see nobody knows. Huh?
As I know, BDFL, which is pretty close.
Which is?
Benevolent dictator for life.
Oh, that's a good one too.
Beat off.
Yeah. That's big design up front. Right? The philosophy that says we're going to figure out everything ahead of time. We're going to get all the specs. We're going to create this monster specification. We're going to come up with everything we need to know, and then we're going to. That's not a hack. And so there was kind of, it was like the mid 80s, I think. I don't remember exactly. I wasn't aware of it, but at the time. But that's sort of when the Agile movement began. And it's more, yes.
Have you ever heard of the Unix philosophy?
Yes. Tell me what it is.
It's like I think it was created by the guys who made Unix, where you're supposed to like decouple code as much as you can.
Right.
Modulate code.
Yeah.
Separate like different components from each other.
Who can give the more distilled version of the Unix philosophy? Yes.
One thing well.
Yeah. Do one thing well. Write your app or your module or your class to do one thing well, and then make it so you can plug them together. So that's the Unix philosophy. And you know, when you look at things like single responsibility principle and object-oriented, it's a variant of that. Actually, funnily enough, I just added to my collection here. Programming rules, is that it? I just read this, Rob Pike's rules. Rule 1, you can't tell where the program is going to spend its time. This is what I was talking about. Bottlenecks occur in surprising places. Don't try to second guess. Rule 2, measure. Don't tune for speed until you've measured. Rule 3, fancy algorithms are slow when n is small, and n is usually small. Fancy algorithms have big constants. Until you know that n is frequently going to be big, stick with the simple algorithm. Number 4, fancy algorithms are buggier than simple ones, and they're much harder to implement. Use simple algorithms. Number 5, data dominates. The reason I brought this up is because in this footnote he says, no, it's not here. I thought he was talking about it. Yeah, you've got premature optimization rule of all evil. We've heard that. When in doubt, use brute force. There's a lot of these little slogans. But I thought it was mentioned. I thought of it because I thought it was mentioned here about the Unix way, the Unix philosophy. Anyway, these are useful and universal. You'll see them in many different contexts. Things get reissued all the time. Okay. Guess what?
Oh, it's like Master Fu and the Programming Prodigy.
What's that?
Master Fu and the Programming Prodigy.
What is that?
There was a time, actually it's like a long passage.
Where did you get it?
I found it on Reddit about like programming.
Who thinks programming is a lot of fun and likes to do it all the time? I feel like it. Hands on out here. Okay, just curious. What?
I like it unless it feels like it's been like 2 days and no progress.
Yeah.
That's when I hate it.
We all go through that, where you beat your head against the wall with something really stupid and you can't get it to work. What do you do when that happens? You know about talking to the duck?
Oh yeah.
Rubber duck, yeah, you know that? Yeah. Okay. But also go to Stack Overflow. Who has already, during this course, posted a question on Stack Overflow and gotten an answer? Whatever. Where'd you put it? On Facebook what?
I said I posted on Facebook about an answer.
Was it something about when the party's going to be, or was it a technical?
Like what sentence did I use for
Okay, but Stack Overflow is a bigger audience. But it's no problem. I don't really care. I think the main thing is to get over. I mean, people go like, "Why do you always talk about that privately?" And I say you'd be amazed, but students for some reason have a big reluctance to doing this. So I'm always like insisting do it because it's so satisfying. One course I taught, one of the students said, "I wish there was a Stack Overflow for life, so I can ask my life questions because the answers are so good." What?
Isn't that
What's that?
Isn't that Quora?
Yeah.
Isn't that what Quora is?
Yeah. Sorry.
Why people answer these questions in the first place?
Why did they answer them? Okay. Why do people answer them?
If you get enough big ratings, you can put it on your resume.
Resume.
Wait, what?
Oh really?
Yeah.
Wait, what?
People recruit based on if you're like a professional.
Okay, I was just wondering if there's
People can recruit.
I think people's charity only goes so far.
People's what?
Charity.
Oh, you mean people doing? There's certain kind of people, maybe not you, who love doing it, and you'd be amazed.
I was raised in a
Don't
very
laugh too
Catholic
much, because I
society.
get you next.
I was raised in a very
It's kind of like why Wikipedia works.
Yeah, exactly. Yeah. I mean, there's a certain pleasure in being thanked and getting the right answer, but there's a certain kind of person who just loves doing it, and they will do it. Well, go look on Amazon and see some crazy people that post like thousands of reviews.
Also, they all get like free stuff.
Wait, what?
You gotta reach the thousands. I mean,
Yeah,
the ones that
like once you get into Vine, you just get free stuff all the time.
he's going like, wait, what? Wait, what? All this stuff.
Oh yeah, so much effort.
Before you just Stack Overflow
It's not worth it.
Stack Overflow for life. You like that? That's a project.
Well, there's the benefit at the end.
I'm fighting with my girlfriend. What should I do? Right.
Yeah, you
Find
give me
it
like
with
a
5 second pause in the situation.
Okay. So I didn't talk about any of these things, and we're sort of out of time. I'll pick one real quick because I think I can do it quickly.
Cloud deployment.
Sorry.
Cloud deployment.
Okay. He speaks, he gets. Cloud deployment. Basically, this is a quick little taxonomy of the X as a service lingo that you hear. You've all probably heard of software as a service. Software as a service would be examples, classic examples like Google Docs, Basecamp, Salesforce. These are complete solutions that basically are sold with a subscription. That's software as a service. That's sort of the highest and the most specialized.
Oh yeah, like what's it like? What Adobe Creative Suite is doing now?
Yeah, exactly. Although that's a little bit because they download the app for you to run, so it's not quite, but it's related. That's the first tier. And the differentiation from company to company is what's the functionality? Is it a photo editing app? Is it a music app? Whatever. The next tier is platform as a service, which is I have an application written for a certain platform, whether it's for Rails or for Python or for whatever, and I can package up that application and deploy it to the cloud. And so we have Heroku, some AWS offerings, Google App Engine, Pusher. That's not really a good example, Pusher. And they're differentiated by what is the platform. So it's only interesting if I'm coding in the right platform. If I'm coding in Node.js, I want a platform as a service solution which supports Node.js, right? So that's platform Another one is called infrastructure as a service. Infrastructure as a service is bits of technology, bits of plumbing that you need to build a system, which by itself is not really useful for anything. And you've, I don't know if we've used them in this class, but things like Amazon EC2 or S3, which is storage, or Google Compute Engine, and there's lots of these. There are bits and pieces of functionality that you can use to build your app. One that we use, I think we're using in this class, I demoed it, is Pusher, a bit of functionality to use to build an app. That would be called infrastructure as a service. You have DNS as a service, any number of things. And they're differentiated again by what partial bits of infrastructure they offer. Now, this distinction is not, eternally important. It's just interesting to see all the pieces that make the whole cloud phenomenon. So we're working with Heroku. Like take Cosi. I mean, that's almost not even here. I suppose I would call it part of infrastructure as a service. It's only used as a bit of an application. You find things below this even is you can pay by the month for a Unix node that sits in a rack somewhere you don't even know where it is. And there you're literally getting the whole computer. So I wouldn't technically call that cloud because you're just paying rent and somebody says, I will install a Dell, X2000 for you with 16 gig of memory and 500 gig of disk, and I will make sure it has power, and I will make sure that it's on the internet, and I will make sure that it's got air conditioning. But other than that, we don't do anything with it, and it's your computer. We can do that, and it's very cheap. You pay like $15 a month, and you get that. But I think that phenomenon is kind of passing. Everybody's now going for cloud services where you really don't know what computer you're on, and in fact, you probably almost definitely don't have your own computer. So there's this whole mess of different cloud options. Whenever you find, and I'll talk about this in one of the scaling lectures if we get to it, something like Redis, which is a network caching service, you can pay, that can be a cloud service. You can pay $5 a month and get your Redis server. You don't even know where it is. You can get a service to send pager messages, SMS messages. You pay for that a month. So all the bits and pieces of your application can be found in the cloud service. What are some of the trade-offs? Well, if you think about a production system, i.e. somebody's paying you to run your business, and you're running it on a service, you have to sort of wonder, what kind of uptime, what kind of terms of service can I offer my customers? I mean, I'll say I have a service to run the billing of a dentist office, and the dentist is paying me $200 a month to run this thing. Well, the thing can't be down, and I can't tell them, oh, sorry, I'm using pusher.com, but their service crashed and everything stopped working. So one of the dangers, of course, in partitioning your app into all these bits and pieces is that that you're suddenly relying your own performance as a business is now dependent on others. We're going to 10 of, right? Okay. Another thing that's very interesting that you may or may not realize is that a lot of services that are themselves infrastructure as a service are using somebody else's cloud service to run on. That's why when Amazon EC2 dies, and happens occasionally, that suddenly Heroku dies as well. And Netflix dies as well. Because all these guys are providing their services running on top of Amazon's plumbing. They have figured out that it's actually, for their business and for their objectives, more cost effective and more efficient for them to run on somebody else's cloud service. The other thing that is said, I have not investigated this myself in detail, is that if you think you're better off buying a Dell 1000 computer in the rack at a company like Server Beach, for $15 a month, you're better off because then you control the whole thing. You might be wrong. It actually, if you look statistically at the uptime of Amazon services or Google services, they're actually significantly higher than, for example, what Brandeis LTS gets on their computers. Because it turns out to be very, very difficult to have a system that's up all but 3 minutes per year. Very, very difficult. And that's the level of reliability you get out of an Amazon. So while, so my point is there's layers within layers in making this decision. And if you're not playing around or prototyping, but you actually have a service that people rely on, you spend a lot of time thinking about these questions. Pricing. So these things are all priced differently. You will often find, and again, this changes as people experiment. People ask me sometimes, so if I have to deploy this app, is it cheaper or more expensive for me to run it on Heroku or on EC2 or on DigitalOcean? And the fact is that on purpose, I think on purpose, these services are priced in ways that make them very difficult to compare to each other. They're priced in very complicated ways. Like even on Heroku, to figure out how much you pay if, for example, you decide you want a higher performance database server, it's very hard because it has to do with the number of records, how often you access it, what you access it from, and it ends up being a very difficult calculation. My advice to most people, if you're working with a language that Heroku supports, is use Heroku, pay for it. It's a very, very good deal, and wait until you have so much growth that your monthly bill to Heroku comes to like $100 or $200, and then evaluate whether you want to switch. Because the reliability and the convenience and the productivity you get out of something like Heroku is easily worth the money you're saving, the extra money you might be paying. I want to alert you to two new technologies, which I'm looking at with great interest. There's something, and I can't demo it because I'm just looking at them, but they're pretty new. Very new is this thing called Flynn. Flynn, the way I understand it, is Heroku in a box. So I'm going to talk to LTS, for example. I think if they run a server, a set of servers with Flynn, we can have an internal Brandeis-owned Heroku. But it could also be if you're running a company and you want to have the convenience of Heroku and the productivity of Heroku, but want to run it on your own box. So Flynn is a very interesting technology. It's not as hot as the next one, which is called Docker, which is not as new, but it's still fairly new. And I think that one is really, really important. And Docker addresses the problem in a way, if you think about it. If I have my application deployed on EC2, on Amazon's infrastructure, AWS, I guess, Amazon Web Services, that's fine. I have to write code to deploy it to the database server, to deploy it to the EC2 server, and so on. I may have to run a web server on top of it. I may have to run a name server on top of it. Anyway, deploying to my application to an AWS, Amazon Web Services, is a pretty elaborate process and basically locks me into Amazon Web Services. Typical, even a simple application, will have at least a web server, a database server, often another server to handle proxying of the web traffic. So you right off the bat are installing various things. So Docker is a tool that allows you to package a completely configured set of services like that in the moral equivalent of a zip file, and then you can deploy it onto any number of cloud services which happen to support Docker as a format. So for example, soon, if not already, AWS will deploy a Docker, package as one unit. But you can take that same Docker package and deploy it onto DigitalOcean or onto your own server. So it's an isolation layer, essentially, to let you deploy complicated infrastructure, multi-computer infrastructures, in a standardized way, so you're not as tied to one service. Docker, if any of you end up working at a software company that does web stuff, almost guaranteed is going to be, because that's really, really hot right now. Okay, good. Questions about that? That's sort of a general overview. Yeah.
Why do I want a Heroku in a box? What do you mean by a box?
Okay, what I mean is this. You know Heroku? How you can deploy and it'll check the database, run MySQL, migrate, install it, run it, send you look at your bundler, all that stuff. Well, there's Heroku equivalent things for like Python and all that that are equally convenient. What if you want to do all that, but you don't want to send your valuable copyrighted source code to this mysterious company called Heroku, because you're General Electric and you want to have your own Heroku. So basically this lets you create your own Heroku. You provide the hardware, you run Flynn on that hardware. It could be multiple servers, and now you have an internal website that operates something like a Windows. That's what it's for. Good, thanks for that question. Yes?
How would you provision different hardware, and how would you say that this machine is going to be a web server, this is going to be
In the case of Docker?
or any similar?
Well, generally, it follows a similar, it mimics the procedure you would go through by hand when you're doing it. So you basically declare, I have a node, I'm going to call it a web server, I want to first install Apache, now I want to change these configuration files, I want to connect this IP address. Okay, now I have another category of server, we're going to call it the database server. Okay, I want to install, Ubuntu version X, now I want to install Postgres, now I want to configure it this way. And basically you specify through a declarative language in Docker. And then you get this bundle, and it includes also commands to create virtual machines using Vagrant and one of these things. And you get the self-contained bundle, which you can then deploy to a service. They also have this mechanism, which I don't really understand yet, of canned Vagrant packages. So you can grab a validated Vagrant package that's for a Rails service and just say, I want to use this one. Or you can use that and build yours on it. So that's kind of cool. Okay, so everybody tomorrow, 5 to 10 minute presentations each project, to-do list, and the demo. Okay, thank you.